Yeah, welcome everybody at the discussion or developer meeting of November 22nd, 2023. Well, my name is Kimberly Mugar, but Ramon is not here yet, so he'll probably join soon. So yeah, the agenda of today is going to be about 3D planning. So we're definitely going to have a lot of discussions about that, and because it's a discussion meeting, we're mostly going to have discussions. So yeah, and then also kind of like a couple of announcements and the next meeting. Actually, I'm going to already do the announcement now. I don't know if anybody noticed, but Ramon's ROSCON talk is out about the difficulties of getting into aerial robotics and the story the fictive figure that we've made up, Mary, going through the experience of getting to know about aerial robotics and how to actually. Hold on. Yes, hashtag we are Mary. Yes, we all know. Also, the Aerostack talk should be out as well. Aerostack 2. We had a presentation about that. That was actually the first presentation that we had all the way in April, I think. So go and check it out. I don't know if anybody else wants to share something or an event or announcements. Just put it in the chat or say it out loud. Because if there's anything interesting to come
Um,
out.
I'll be speaking at ROSCON Bangalore. It's not aerial robotics, but yeah, anybody who's coming to come say hi. It's the first time India's doing this, and this should be fun. There's a lot of stuff about ROS2, Xeno, and some crazy stuff that people at Acceleration and other places have done. And I'm going to be giving a talk on why my company uses ROS when we don't even build robots. So I guess that might be interesting for some who are in this space. Yeah.
All right. Yeah, thanks, Mayank. Yeah, of course. Yeah, Roscon India, and I think also Roscon Germany is also going to be soon as well. So it's a lot of exciting things happening. Okay, so just a very quick introduction to 3D planning. Like TD, of course, like we know all of that 2D navigation not enough, but a lot of ROS packages are based on because they're for ground robots mostly. And I guess what we all kind of think is 3D planning is especially also important for outdoor navigation, also indoor navigation, of course, but especially for outdoor navigation. And kind of like a very global thing, the current planning packages simply won't do, or perhaps will now, since we've had a lot of improvements, I've heard. But that's all we're going to talk about. So this is actually a bit different to the topics that we've already discussed before, because all the other topics we kind of were discussing okay, what's currently wrong with it, what's going to be potentially do in the future. With 3D planning is a little bit different because we already had a head start. So that's great. We were moving too slow with the topic discussions, but that's fine. So Ryan, Jaeyong, Rus, and Mayank are kind of starting with already a bunch of PRs, the current packages that are currently being handled or configured to ROS2 and everything is terrain navigation, which is from ETH Zurich. Yeah, and I guess all of them are from the Autonomous System Labs from ETH Zurich. So math, MAV communication, and grid map GIO, which is based on Anybody's grid map. So those are kind of the packages that things are happening in right now. So there is a GitHub project for 3D planning that we already made. So it's kind of also kind of try out to see how we can handle maybe future subcommittees as well, maybe in a similar way. But if you're interested, what is currently going on in process or what has been already done, or things that you can still pitch in with, I recommend you to look at the 3D planning, project file there. So yeah. So thanks to Ryan, he already gave a some kind of status report about the current state of 3D navigation. So I guess just very short, that a lot of navigation solutions are not possible for fixed wings, because fixed wings are a little bit more difficult, cannot stop mid-flight, fly for longer distance, so actually the curvature of the Earth becomes important. Stricter aerospace regulations, the kind of in general, it gives a good planning burden on the operator or the autopilot suite. There's also kind of current issues with GPS for navigation that we have this course um, threads open, so that already has 38 responses. Poor Steve. It's a lot. Yeah, so and I kind of like the current work currently going on with the package that I've mentioned before. It's like porting into ROS2 to talk about standardization, to fix compatibility issues with different OSs, by means by like the Docker containers and everything, and to make ROS binaries. Yeah, so these are kind of the discussion topics that I've kind of selected. Of course, like I must already say, I'm a very much an indoor navigation gal. There might be things that we would like to discuss that are more particular to outdoor navigation, but we also have a topic about that. So perhaps that is where we can kind of like draw the lines between the two. And I think this is probably going to be enough for 50 minutes of discussion or 45 minutes of discussion. So yeah, let's perhaps go ahead. So one of the people that couldn't join, I'm not exactly sure, like I forgot his name, but they also kind of like was interested like what are current existing 3D planning algorithms out there. I've just kind of made a list here, which are very indoor based. I do realize. I would perhaps like ask anybody of the outdoor navigation community, of course, like terrain navigation by ETS Zurich by Jay Young's research. That's a new package, so that's really cool. That's for outdoor navigation. Is there perhaps any other packages that people can like share here that are perhaps more for outdoor navigation?
So I didn't find
Um,
any. Yeah, go ahead, Mayak.
yeah, I just wanted to clarify that we should maybe draw a distinction between existing 3D planning packages and algorithms. Because strictly speaking, like terrain navigation is RRT star, right? And when people think algorithms, there's a particular class of algorithms that they might be thinking of for planning, like either RRT or A star, Dijkstra, all of that classical stuff. So maybe packages is a better heading. Um, but yeah, I agree with Ryan. When I was hunting, there wasn't too many even I could find.
Yeah, I have changed the title. Thank you very much. Yes, that's indeed a yeah, okay. So like it's like currently like my young and both Ryan is saying like terrain navigation is the only outdoor navigation package. That's purely only for outdoor. I must say that Hector Quadrotor had at least they had like some kind of like outdoor navigation, but I'm pretty sure that they haven't really thought about any type of like Earth fixed coordinate systems and things like that, and things that I'm not super familiar with. But that was at least like the one that I was I think introduced to the most. Um, I've also added maybe like some ones that you wouldn't maybe think about with 3D planning for a UAV point of view, like there's also like the ROS1 3D navigation, which is super old. We have Move It, which is claimed to be a 3D planning a ROS package, but it's mostly for arms. Um, I don't know if anybody tried to actually use Move It in for drones. When I talked to one of the picnic people at Roscon last year, they looked at me like I was a crazy person. So, but I don't know, like does it doesn't make sense to it is an existing capacity for 3D planning. I don't know, but I don't think anybody had tried anything of that one out. Okay, so if these are kind of like the existing 3D planning packages, then let's move on to the next topic, unless anybody has anything else to add.
Uh, I just wanted to ask,
Mm-hmm.
I haven't really used Move It, but isn't it more like for robotic arms and like multi-DOF manipulators? And in that sense, it does satisfy like 3D planning in space. But do we want to maybe, uh, is there already a distinction between path planning beyond inverse kinematics for like a fully mobile agent versus like, let's say, an end effector? Um, or does it end up being the same problem? Like I don't know enough to know if there's a distinction, but that's the background I have about Move It and what it was intended for.
Yeah, it's definitely for like, all the examples I've seen are for robotic arms for sure. But I would say like there's this distinction between like the platform and the actual problem itself. They also have to
Mhm.
move within a space which has like, that they don't have, yeah, that they have to kind of like avoid obstacles and everything and do some planning in that. Of course, you have also 3D planning in the NAV
Mhm.
2 and the NAV and NAV 2. So um, I would say like, it perhaps is more of like better to kind of have maybe more of a clear cut between those. But are you able to make a clear cut or not? I don't know.
I
But
think
yeah.
there's definitely a lot of overlap because in terms of how you represent the world in a local coordinate frame, um, because like they can plan over an octomap representation, which is also used
Yeah.
by indoor navigation for drones, right? In some
Hmm.
cases.
Yeah.
So the map representation at the scales that a robot arm works are, you know, on an order of magnitude is similar to a drone in a warehouse.
Hmm.
And
Yeah.
so you can use that Cartesian coordinate frame for those.
Yeah, and I guess like, of course they have to also kind of assume to do planning with of course the limitations of that arm or the degrees of freedom of that arm, but perhaps like, an robotic like an aerial platform also has, yeah, its own like degrees of freedom. Of course, like if you have a quadcopter, it's a little bit easier. What if you have a flapping wing or a fixed wing in an indoor space? Not sure if that's the greatest idea, but it's, I just kind of see like similarities. I'm kind of surprised nobody tried to do it like something like that for drones. But there was somebody that mentioned something on the chat. Ours is saying that we're rather close to an F2 than move it to, I think. I never used or seen being used for floating base objects on mobile base or drones. Yes. I have seen a couple of ROS answers asking if they can use it for drones. But yeah, perhaps it's a crazy idea, but let's see. If there's no more comments about that, then I suggest to go to the next part. One moment, let me just try to see if I can get this a little bit bigger. Because it's a little bit small, I would say.
You want to present it?
Yeah, the problem is that if I actually present it, you don't actually see like any notes that I'll be taking. But yeah,
Oh, right.
for here, the slide is already finished. But this is pretty readable, I would say.
Yeah.
Okay, so like then the next topic is like the state of 3D planning implementation for UAVs, which pretty much was the discourse thread that you started, Ryan. Which I
Yeah, I would
assume I
say like
read.
overall local Cartesian planning is more of a solved problem.
Yes.
There's definitely still challenges with that in terms of like handling a dynamic environment, but I think that the technology stacks are more available to do
Hmm.
planning in that kind of domain right now. Like TF2, right, is a Cartesian coordinate system. There's no TF2 for geocoordinates.
So TF2, yeah, of course, yeah. I guess although I had perhaps like a topic about that. That was it rep 105. That's like kind of with an option of how to
Mhm.
represent that
Yeah.
with TOF2, but I don't know, like what's that seems to be a little bit more complicated than just like Earth map odometry. Yeah, that I don't think it's probably a little bit more yeah, it needs more data in that sense. All right. So okay, so like planning is more of a solve problem, more packager. For example, TF2 is for Cartesian coordinates only. Um, I guess like if you look at like the transforms are Cartesian coordinates only. What is the like from any outdoor navigation package? How do they solve the solution? Like, is there any maritime type of ROS packages that are able to to handle these kinds of things, or is that just doesn't exist?
It's a good question. I don't know. Maybe Reese knows.
Not that I'm aware of. I think again, most of the work assumes a locally flat coordinate space, so small range. TF2 does have, and Rep 105 does have suggestions for kind of Earth and mapping between the systems, but there isn't really anything that implements it well, and that's the difficulty. So if you want to move from one map to another, keeping track of all the local flat frames and shifting between them and making that easy to use is the bit that's missing. But I think the sort of conventions are there, but a package that actually deals with it all is not available. And for maritime, I'm not aware of something there either.
So like so I've seen that you've also kind of given a presentation on at the maritime group. Like, are you like, do you work with UAVs primarily, or is it like the combination between like maritime vehicles and aerospace vehicles, or like, you know, perhaps you can kind of tell a bit more
A bit
about
of both. I mean, I'm kind of with I've been working in the last year with kind of on ArduPilot with Ryan to put a DDS support in there. So not really specific to particular vehicles. The maritime stuff, I've done some work in simulation there, providing a more advanced simulation environment for maritime vehicles, and a little bit of work again with ArduPilot like a couple of years ago, where there was an interest in having the ability to simulate quad planes landing on ships. So you've got sort of various vehicles moving, but again, all of that was all like local Cartesian frames. So we're not sort of moving out of a space, sort of a 50-kilometer kind of cube type space is what you're looking at. And I think the stuff that we're interested in is, well, at the edges of that, you're going to be subject to curvature. So, and planning over larger distances, then whether it's maritime or aerial, you have the same issue in terms of switching between local sort of local maps and things like that. So, yeah, as far as I'm aware, no easily accessible solution to that in the open source community anyway for ROS.
All right, very good. And I guess, like, you know, for what kind of distances do we like have to, what are we kind of thinking about? Like, you know, it's like, when would you guys agree on that the kind of like the curvature of the Earth actually makes sense to not focus like on only the global coordinate system? Is that like you said, 50 kilometers, or is that longer or shorter? Or should you actually always be aware of the Earth curvature?
I think the thing we've seen, sort of just in some of the discussions, it's to do with the datum that the terrain data might be provided in. So it's a shame Jay is not on the call, because he's really the expert in this, and it's his work that we're kind of adapting at the moment to try and use. But he sort of said a little bit of this on the Discord topic as well. So different countries will use different datum for their terrain databases, because I mean, I'm not a geolocation expert, so but there will be reasons that they'll have for using one particular coordinate choice for getting accurate data. And so as you move from one place to another, you have to be sure that you're using the correct terrain database for that, and that the datum are all aligned. And that's really the problem. So you've got the size of the area that you're moving over where you're subject to curvature, but you've also got the choice of datum for your terrain database. And if there's any misalignment in there, then you can be out by quite a long way quite quickly. So that's the bit that we need to be sure about, is that when we're specifying a local coordinate frame, that the terrain database is mapped into that correctly, to the correct datum, and that may shift as you move from one map to another one. So managing all of that kind of automatically and easily is I think the hard problem, because at the moment you can do it by hand, but it's easy to make a mistake. So I think to make it usable, the key is going to be understanding what local references we want for these frames, and then making sure that as we kind of switch from one frame to another, we handle the conversions correctly, and that most users are not going to want to have to worry about the details of how all of this works, in the same way that when you use TF2 for like general coordinate transformations, it just kind of works. It sort of handles all the complexity for you. And that's what an extension that to geo coordinates should do, I think, anyway. So I don't run it.
So that is a feature that it doesn't exist in TF2, but it
not
needs to.
Not that I'm aware of, no. And because you've got geo-reference data that comes with it as well. So for the aerial vehicles, you're interested in the terrain database, and potentially different quality terrain data at different resolutions. So ArduPilot has a terrain database, but we might want more accurate data for certain cases. And I think that's where Jay's kind of using different coordinate systems according to the quality of data that they have.
All right, yeah, I've sent a message to Jay very quickly if he was planning to join.
He had something come up this morning, unfortunately.
Yeah, okay. It also seems that Ramon is also occupied at the moment. So yeah, perhaps that's maybe some I've seen him answering on the thread, so maybe that will be a good thing to kind of keep it on there. Yeah. So
I'd like to add something regarding the datums.
Of course.
Like a lot of GPS receivers will report position in the WGS84 frame, which is an ellipsoid. And so what that means is it's like an oblong sphere, and it's symmetrical. And there's just a few parameters you use that you can just hard code in your firmware to do conversions between the frames, between that and Cartesian. And so that's pretty easy to do on an embedded system. And all the GPSs report in WGS84 pretty much. But
could you maybe like spell it out for me? It's like
yeah.
No, it's not something else, right?
WGS84.
Yeah. Okay, yeah. Right.
And so that's like what's in the rep is, hey, if it's in WGS84 or frame, then you can put that in the frame ID. So the problem is that that's not very accurate for the Earth, and there's other coordinate systems that use the gravitation field, and they're not symmetrical about the Earth because the Earth is not symmetrically dense or the same width. So sorry, my phone's off. So that the difficulty is that some GPS receivers support some other datums, and your terrain database might not be in the same datum, and there's not really a good library that we can use to use for planning to convert between these datums.
Yeah, all right. So like then datum conversion. If I'm writing something wrong, like I said.
Ryan, do you say does GDAL and Geographic Lib not handle this sufficiently well, or is it more the fact that it's not wrapped up as a ROS package to use easily?
I think there's two challenges. One that Jay said was regarding embedded. Like, this isn't something that the autopilot can do, and really you want the autopilot to know where it is relative to terrain, so it doesn't run into it. There's very few people right now that are doing like a real-time ROS2 in a safe manner, and they rely on the autopilot to do that. But if the autopilot doesn't know where it is, then you're sort of saying, all right, we're going to trust our companion computer can do everything in the right amount of time and never crashes. And the ROS code right now isn't necessarily designed for flight critical. even on small unmanned drones.
Yes. Difficult to rely on companion computer alone.
Yeah.
So I guess
So
like it's a kind of a trust issue as well, like especially if you talk about regulation, let's say, then I guess like they won't let something fly unless it's like, foolproof, let's say.
yeah. And
Yeah.
so that's one thing, is that it's not available usually for embedded, because it's a lot of data. Like this device here is the Trimble PX1. It's a GNSS receiver that gives you 1 centimeter position globally in Earth frame, and it supports 2 different coordinate systems, WGS84 and what's the other one? EGM96, and it has a database on it to how to convert between all those. But it only supports those 2, right? So if your terrain data isn't in either of those datums, then you can't really convert.
Wow.
Um,
That was,
Hey, I had a point. It might be important to kind of specify the operational envelope where all these concerns become valid. Um, what Jay's research is doing and what we're trying to do here is kind of very challenging for fixed wings. So you can't even like arbitrarily position it in the z-axis. You need to do loiter maneuvers and go up and down in height in mountainous terrain. But let's say if somebody's working on a much simpler use case of using a quadcopter which has an endurance of only up to a few kilometers, it might be important to draw the distinction that these are the factors of the use case that we're considering, which warrant these discussions or these design decisions. And kind of this is the expansive operational envelope. Because I think Kim already asked this sort of question that, hey, when does it become important that we consider the curvature of the Earth? Maybe it's at the order of 50 to 100 kilometers, or maybe it's X number of kilometers anyway. But yeah, it might be important to specify that, because for several outdoor use cases, which are, let's say, just doing mapping of a farm, which is a very small size farm, these concerns classically have not really come up. So I think for context, when we're doing 3D planning, it does become very important to set the use case right as to why we're going into these, literally pushing the boundaries of the systems that exist today. Just for context, for a lot of people who will come across these packages and look at whether or not it satisfies their use case and whether it's relevant or not.
all right. Anybody else has something to add to this discussion?
Yeah, I think maybe it's important to note, like, a lot of the autopilots use a relative to home altitude for all the mission management. Like, although when you do waypoints in ArduPilot, by default, you do the altitude relative to home, because your GPS initializes, and even if you're on a different datum, that's basically a fixed offset for most of the applications, so it doesn't really matter. And that's a way around the problem, is just to use relative coordinates to where you took off from.
Yeah, instead of like absolutes, that's which is a lot more prone to these conversion errors.
Yeah.
Yeah, that makes sense. I guess like for indoor navigation, that's usually also relative. True.
Yeah. A use case I gave for, concrete use case was drone delivery, because you need to take off from a certain place precisely, fly a significant distance, and then go back down to the ground to drop something off. And unless you just say, hey, we're a quadcopter and we're going to descend vertically and use a laser rangefinder until we encounter terrain, even if it's 100 meters different than what we thought it was, we'll drop the package once we get 2 feet from the ground. For planning purposes, the problem that we're running into is airspace. So in the US, for right now, at least, you're limited to 400 feet for commercial operations. And
400,
yeah,
400 kilometers?
No, so 400 feet vertically, which is 130 meters or something.
Oh, okay,
Yeah.
yeah. So, okay, yeah. Because of like 400, I thought that you said 400K. It's like, whoa,
Yeah.
that's a lot.
No, so I
Feet,
mean,
feet.
yeah, so you have 130 meters vertically that you can be from the ground. And the terrain database that the autopilot uses has an uncertainty of plus or minus 30 meters. So you need to already like fly 30 meters, or I think it's 30. Don't quote me on these numbers. I'll have to look them up again. But yeah, so you cut that down by the uncertainty of your training database, and then you take into account the operational constraints of your vehicle, right? That you can't climb as fast as you want, and so you're flying towards a mountain, and you have this airspace, and then the mountain gets really steep, and you can't go vertically. So the only way to get around this is to start circling on fixed wing, and that's really what terrain navigation can plan for. And the autopilot can't do this because the math is too complicated. So like what the autopilot does is it does like a look ahead. And it says, oh, based on my climb rate, I need to start climbing when I get to here so I can get above the mountain. But then it's going to breach your airspace. So we'll fly illegally.
All right.
Yeah.
Yeah, that explains a lot. Yeah, I feel sympathy for you guys dealing with outdoor navigation. This this is just one of those things that just comes on top of like all the airspace regulations that you have. Seems like indoor navigation for aero robotics is much easier than, but yeah.
I just dropped a link in the chat, which kind of shows what Ryan's saying. So from Jay's research, which shows a very nice demo of where his planner works and how it does the loiter maneuvers and all that, which is listed on GitHub as well on the terrain navigation repo. So if anybody wants to kind of get a feel for what Ryan just described right now, it's a really nice video to kind of, I think in the Swiss Alps, he's done like a planning demo of how the companion computer would be planning complex trajectories, which typically wouldn't happen on the flight computer itself. To handle this case of having a fixed wing, which gives you the endurance that you need, but has the drawback that it's unlike a quadcopter, you can't just position it arbitrarily. You need to do circling maneuvers if you want to like stop in one place, or if you want to ascend or descend and change altitude gracefully. So yeah, those kind of constraints.
All right. Yeah, thanks for the link. I've put it in the slides, and cool. Is there anybody else that would like to share more about the current state of 3D planning for UAVs? We're going to have more topics later as well, so we're probably going to mention some of it. If not, then I'll be going to, okay, we've been talking about the burden of autopilot suites already, so I've kind of moved this up because I think this might be a little bit more thing to talk about, like specifically what should be handled by the autopilot and what should be handled by a companion computer. And I guess we can already put in here, like, these like complex like flight maneuvers to like avoid illegal or like airspace or obstacles.
I think perception beyond basic optical flow, if you're doing anything which is like SLAM or intense perception stuff, I think that's usually the number one reason for offloading to a companion computer, because processing RGBD data or camera data for obstacle avoidance or anything like that. So anything which doesn't have to be real time to the order of actuator control, I guess, like down to microseconds, but is important enough for, let's say, a 1 second horizon. I think that sort of falls in the purview of the companion computer, as far as I understand.
Yeah, I think I've read a paper about it once. Like, that at least the autopilot should be able to like deal with things on, microseconds type scale. Although, like, companion computer can do that much slower, perhaps. Yeah, how do you say, like maybe 100 microseconds, or like kind of really depends like how quickly you want to have it. But yeah, so can be a slow, let's say, a slower feedback loop.
I think you had a nice slide on that from Ramon's talk as well, right, Kim? Where the actuator control or the low level stuff is done by the flight controller, and then a slightly high level behavior is on the companion computer. And let's say if you happen to be in a luxurious environment where you have like a wireless link to a base station, the even higher level behavior for like mission, this stuff.
Yeah.
I think this sort of covers it, no?
Yeah, I guess so. Of course, like this is very broad, I would say. like for the difference, like trajectory control and high level control.
Mm.
Yeah,
Yeah,
it is
because
something that
I
can
think
be handled on the companion computer, but it is, but you can also have, for instance, like trajectory control all happen on the FMU. So yeah, that's a bit of a choose. That's
I think the exceptions start happening when you start hitting limits of processing or memory and things like that, right? Maybe the companion computer is needed because the FMU just doesn't have enough RAM to like hold the entire space representation in memory. You're
Mhm.
talking about 3D now. There are voxel grids at play. Even if you're doing like slightly lower resolution, it might not be reasonable to assume that you would want all that sitting on the FMU. Of course,
No, yeah.
these sort of statements go out of fashion real quick as soon as we go from an H7 to like an ARM Cortex A suddenly becoming like an FMU in let's say 5 years from now. But as RAM increases, things become better and all of that. But I think generally speaking, it's fair to say that data intense applications, heavy compute, which maybe requires embedded GPUs or a lot of single instruction, multiple data, SIMD kind of stuff, is better left for companion computers, while low level stuff, which is death or safety related, is better offloaded to the FMU.
Yes. Although the safety is also sometimes also kind of really reliant on the
Yeah.
yeah, on the map data and what's like or what position you're in. So I guess like the FMU should be at least aware of
Mm.
it, and it needs to be accurate. Like if you're flying in a space which has a geofence, and due to like perhaps your companion computer's like, oh yeah, I'm here, completely off, and then it gets, and then suddenly like there you have some other element on your platform that has some kind of trigger. If you cross a geofence, it will just fall out of the air. Then you're kind of screwed. So
I
yeah.
think that's a very valid concern about interfering systems when it comes to fault tolerance and like fault trees. Like, what if the FMU says one thing and the companion says another? Do you have conflict resolution mechanisms, or do you have override mechanisms, or some inherent priority? I think that's definitely a major discussion in safety, because you can either have like a hierarchical system of control, or yeah, like battery fails, flight controller just says, "Hey, land now." Uh, but let's say if you're off by a couple of meters, a geofence breach is not as bad as stuff catching on fire. So it's kind of like
Mhm.
you need to have a hierarchy of faults, I guess.
Yeah, yeah, true. Although, like, I think with geofence, it really depends on the country that you're in. But in some, you usually have
Mhm.
like two layers of like geofencing that you need to kind of have something or go back, and the final geofence that you would just need to get. It will just like shut off completely. So,
Yeah.
um,
Or they blast your drone with a ray gun.
yeah, that's a very also a geofence, a bit more externally executed.
So
Yeah.
could we add a column for an item for like what's a burden of both suites ideally? And to me, like both need to be responsible for having idea of the terrain as well as the airspace or geofence.
Wait one
Because
moment. So it's for both.
both both need to know about essentially the operational space constraints of the vehicle, which is terrain, airspace, and geofence, at least right now. Maybe there's other things later, but that's the key ones.
Yeah.
That if
What was
you're
the first thing you said? Like terrain, geofence, and there was one more thing.
airspace constraints, like
Airspace constraints. Yeah.
yeah, which is similar to geofence, just that
Yeah.
one's user controlled and one's controlled by your government.
Yes. Is there any other
Are there,
burdens that both the MAU and the companion should be aware of?
is velocity
So
or acceleration usually uh, something that
yeah,
is
they need to know
regulated as
like
well?
they both need to know where the vehicle is in space.
No, no, not just to localize, but let's say I have a quadcopter at 2 kilograms, right, carrying some payload. Because crashes would usually come from the momentum of the crash, like mass times velocity. So maybe it's not legally allowed to fly that at 200 kilometers per hour. You might have the capability to do so, but as a part of the operational envelope, there might be a maximum velocity in addition to just the geofence of XYZ of
Mhm.
lat long, where like of a and time as well. Yeah. Like certain geofences are time based as well, whereas like your flight map gets approved only for a certain duration and things like that. But I feel like velocity might also be something that gets regulated if it's not already.
Doesn't it kind of go around the operation space constraints, but I can add like like
Hmm.
maximum velocity or something like that. I think that's usually what they are aiming for. Like acceleration is not usually what they put constraints on, but yeah, velocity I can imagine. Okay, so is there anything else that we can add as like a burden of either the companion computer or the FMU or both? Um,
I think it's to be determined where the datum translation lives.
mhm. Yeah, I guess like well, let's make another column. Unknown. Let's say where does the data translation happen? And do you mean with that, like for instance, like the map conversions, like what you have with outdoor navigation, or what do you
Yeah.
mean with data translation?
Datum with an
Datum.
M.
Oh, datum. I was like
Yeah.
data. Okay, datum translation happen. Okay.
Because
So
the
yeah.
GPS can do it, the autopilot could do it, or the companion computer could do it, or all three.
Like companion or all three. It's one. All right. Okay. I think that's probably good for now. Let's move on. We have about 10 minutes left. So let's move on to maybe like, perhaps I was supposed to make a poll for this, but maybe people can just do yeah, let's say an heart if you're more an indoor person, a navigation person, or a like party thingy if you're an outdoor person. We can kind of give an indication of so for instance, like I'm more of an indoor person, hearts. So I see 3 hearts. There's no outdoor like the other party one, or like the house he calls. Yeah, Ryan is indeed outdoor. Yeah. All right. All right. I see a couple of raised hands. Was that for a question or was that for indicating that you're indoor or outdoor? So it seems to be a bit 50-50, I feel, at this moment. Perhaps a little bit more indoor navigation people than other. So, of course, I would just put like, what are the things that indoor people navigation have to worry about compared to outdoor navigation? I would already put in here, like, we don't have to worry about the curvature of the Earth.
Yeah.
So that's an obvious one. And fixed wing vehicles, that's usually not indoors. But what else? If anybody can just blurt something out in this brainstorm.
Outdoor
So
guys have GPS. That's the biggest advantage we have, right? Outdoor people have GPS, and that solves so much. Indoor guys have to put like 3x the amount of cameras and different sensors and VIO and SLAM and all that just to figure out where they are. And even then, that's not enough. And sometimes environments don't allow you to put positioning systems like, let's say, what's the popular one? RF based ultra wideband. Like UWB
Mhm.
is not always on the table. You might have to do something with either Aruco markers or like just with features in the warehouse, and then suddenly you're staring at an empty wall and everything goes to shit because there are not enough features in the environment. That's something that outdoor folks don't have to worry about. They can fly over grass because they have GPS. We guys look at grass and it all looks the same, and our copter crashes down.
Well, although I would rather have grass than how do you say navigate through a hospital.
Yeah, for sure.
Grass at least has texture. There's more texture than you think. System in place. Yeah. So outdoor also has, they have different system, but it's also like R2K, for instance, but you have to kind of like add that. Outdoor also has more natural, features for optical flow if you need that. More natural features. What are like, I guess like disadvantages for outdoor is
They have to deal with wind. Indoor,
wind.
usually wind is not a concern unless you're working with crazy flies, I guess, and you turn on that one fan.
The don't let the crazy fly into this. The crazy fly is very bad. Yeah.
Yeah, I mean, if you have something
Air
which is a
conditioning is
couple
also
hundred
very bad for
grams,
the crazy fly.
yeah.
So either can have to handle with winds, and I would say outdoor also has to handle with more regulation as well. Strict regulation. I don't think there's any regulation for indoor flight. Like, it's it's kind of up to the university or institutes.
Indoor flights usually are around people, so that's a big disadvantage. Outdoor flights, you can very easily clear the tree line or clear like humans. You might have to worry about power lines and things like that, but you don't have like it's not a valid concern that you might bump into people or things. Like obstacle avoidance is, I feel, a bit easier and more conservative to the point of maybe path deconfliction when it comes to outdoors. Indoors, it's a very proactive and an essential element of your navigation stack that, hey, there's going to be stuff you're going to bump into. There's going to be wall effect. You're going to bump into people, other
more
robots,
more obstacles, like static and
and
dynamic.
dynamic. Yep.
Although like it really depends. Like apparently, like drones cannot really join the commercial airspace. Like if there's any people that have to handle with like planning with actual commercial airlines, like it's like they'll probably say like there's a lot of stuff in the air. But of course, there's like there's more, wiggle room. Let's say.
At least as of now. Slowly, you
Yeah.
need UTMs for coordinating all the drones in the air. But as of now, where we are, like 2023, I think, it's just harder indoors.
Yeah. All right. Anybody else have more to add?
I think one of the biggest challenges outdoors is the risk of flyaways. Even if you have a geofence, there's always that small chance that something goes wrong and your drone disappears and you can't get hold of it. So I think people who work outdoors have to have a lot of redundancy in the safety. So you have to make sure you've got an emergency stop, that you can regain manual control, that your comms is always up and running, that you have your geofence. You just have to have so much redundancy.
Mm-hmm. Yeah, that's absolutely true. I've participated with some competitions, outdoor competition. Now, I haven't participated, but I watched outdoor competition for UAVs. Yeah, I've I've seen some things that probably the government should not know about. A lot of flyaways, let's say, not good. Yeah, so it's risk of flyaways and a lot of redundancy safety, absolutely. Anybody else? Anybody else wants to add something to this?
I think like indoor generally is more dynamic environment. You have moving things that you need to account for, whereas outdoor, aside from other vehicles, things are pretty static.
Yes. I
Not
think
a
I've
lot.
already mentioned that before, but it's also good to mention that for outdoors indeed. Yeah. Cool. Okay, I think it's fine for now because we're getting a little bit. Usually, I would like to start finishing up 5 minutes before. Let's say we still have like something about standardization because there was some mention. It's very difficult to coordinate autopilots for ROS usage. So I guess like the question also here is like, in terms of navigation, like where to apply standardization, what needs attention. Is there anybody that would like to comment on that? Like, to give some thoughts, like why it's so difficult to make a, let's say, how do you call it, like the autopilot agnostic navigation messages?
Yeah, I mean, I think goal communication is something that's not solved. And how do you communicate a navigation goal from a high level companion computer to a low level autopilot? It's not waypoints.
Yeah, so you're not, yeah, so what is the, like then, what is then the difference in your opinion about between a goal and a waypoint?
Well, a goal, like, so in navigation, like if you look at what Jay did, he has a panel that you can select an end location that you want to be at, but it's a 3D vector. And so we don't have a UI to do that right now. And there's not a standard ROS message for communicating that I know of.
And a waypoint, okay, yeah, so a waypoint is actually, it needs to go there no matter what. It's not the end goal, but it's kind of like part of the path
Yeah.
planning.
Yeah. It's
Okay,
different
yeah.
than a waypoint, right?
Sorry?
A waypoint, yeah, I mean, it's sort of like a waypoint, but you actually, like, you might have a vector that you want to be facing when you get there.
Mm-hmm. Yeah.
And I think it's just important to note that, like, in RViz, you have a 2D nav goal, but you don't have a 3D nav goal supported yet.
Yeah. Yeah, I think that's our RViz only 2D goal available. But I guess that's also like the nav2 plugin that they've only enabled that.
Yeah, or sorry, in nav 2, yeah. And then another thing for me was the assumption about datums right now and all the navlink messages. They just say it's an absolute frame, but they don't say which one.
Yeah, okay, so that's from the MAV link.
Yeah.
Messages.
And
but
I think it's assumed
yeah.
you're in WGS84.
Doesn't say which formats. And the last thing you said, like it's now standard for WGS84. Is that what
Ish.
they're assuming?
Generally, yeah, but I don't think it's always, as we pointed out, I don't think it's a great assumption. And at least needs to be documented better.
Yeah. Okay. 1 moment. Let me. It's not a great. It's not great. Also not mentioned. Luckily, we have the transcript of this all because I'm a terrible notarist. Let's say. All right. So it will be quite difficult to use 3D goal in RViz. There's no proper depth processing using in 3D. Yeah, that's indeed an issue. And I think Ryan has already left for his next meeting. So I think it will be good to kind of like close things off here and here because I think we've discussed plenty and at least like we know kind of what's the status, what is wrong, and there's a lot of work being happening in at least like the outdoor navigation part. So let me just do some final announcements for this meeting. But before I move on, is there anything else that anybody just likes to add? Just one sentence. Then, but also we have that nice thread of 3D planning that we can also add some of our ideas or comments as well. So let's kind of start to wrap up. This meeting we had already, like, we had a lot of developer meetings and discussion meeting about different topics. And these are all the kind of like the ones that's the had done behind it. It's the ones that we have already had a meeting about. So the kind of least like autopilot suite for UAVs, safety management systems, legally and airspace access, aerial vehicle types. But let's see, like we have to, of course, like start dealing with these. Yeah, probably next year. Because I think the last meeting of this year, I would like to maybe talk about like, what's next and is there already groups that we can start. So the upcoming meetings is we only have 3 for this year left. 3D planning now. We have a presentation meeting in next up in 2 weeks, and a discussion meeting about like just kind of a wrap of the year. So the next meeting is going to be about Autopilot and ROS by Ryan. I hope he's still available, but he said yes. So, and that's on the 6th of December at 3 p.m. Universal Coordinated Time. Also, if you would like to add a presentation or give a presentation or just talk about the topic that you find important that we should talk about, please send me an email or Ramon an email, so that we can kind of plan you in for a presentation meeting in the new year. Then it's going to be in January for sure. And also we have a GitHub repository for those that don't know, the ROS Aerial GitHub organization, where we have some information pages that you can add yourself as community as a member. And also, as I already showed before, we have the projects pages of different subtopics that people are already working on. For now, just 3D planning. Yeah, so that is pretty much it. So I'm going to close the recording, and I would like to thank you all for joining and participating with this discussion.